All right, so welcome everybody to our first ever AMA with the ZKM team. I'm Kat, head of marketing, and then we also have Kevin, the CEO. We have
Hello,
Pavel,
everyone.
our DevRel lead, and we have Payman, our researcher. Go ahead and introduce yourselves, guys. We'll start with
Hey.
Kevin.
Oh, yeah. Hello, everyone. My name is Kevin. I'm the co-founder and also the CEO of the ZKM. So we're nice to join this community call and to communicate what we are building, what we are looking forward in the near future. Yeah.
Awesome. Payman, go ahead. Okay. Or Pavel, haha.
Oh, sure. I guess we'll go in alphabetical order. So, uh, I'm Pavel, the DevRel lead for ZKM. I'm in the chats helping with certain types of questions in terms of like developer, how the application works, how ZK proofs work. Just essentially, my role here is so that everyone is informed about what ZKM does and how we can apply ZKM into use cases that can be accomplishable within a shorter period of time. There's long-term vision, and I'm more oriented into what can we do, let's say this year. So that's me as a summary.
I guess it's my turn. So yeah, I'm Payman. I'm one of the researchers in the ZKM team, and really happy to be here and connect with the community and get some feedback and update you guys about what we've been doing and what's the plans for the future. My main role is like keeping us up to date with the recent developments on the research side and design side of like other major ZK projects and figuring out the engineering details of our products and like designing the ZK architecture for the close future and like long-term plans.
All right, awesome. Welcome, guys, and thank you. So I kind of want to go over some of the basic questions, just an overview of ZKM. And as you guys start asking any of your questions, we've been collecting them for the past week as well. But we'll start off with kind of an overview of ZKM. So Kevin, can you kind of just go over what is ZKM, what it stands for, and what we're working on?
For sure, yeah. Actually, ZKM stands for a lot of things, but generally speaking, is a general purpose ZKVM for verifiable computation. I think most people here understand that for a lot of blockchain projects, computation resources are very expensive. So there's a need that we need to bring computation off-chain. But by doing so, it will bring another question, how we can trust the computation result. So that is actually ZKM is doing. We treat every transaction, no matter it comes from layer 1 or layer 2, as a computation. This will be compiled to MIPS and then going through all this ZKVM process and then generate the proof, validated proof by smart contract. So in this way, it's a very decentralized and secured way for verifiable computation. And I think verifying it by a smart contract is also the most decentralized way. You don't have to, trust a committee or someone to verify the result. So that's basically ZKVM is building. But although we are building this very hardcore technology, but actually this project starts from some very interesting background. I believe I shared a little bit in the group a couple of weeks ago. I hope to reiterate. We actually started from use case. Why do we really need a ZK VM in this such a low infrastructure layer? I think it was back to 2022. One of our co-founder, Peter, he met with the founders of Arbitrum and Optimism. At that time, they were discussing about how OP can compete with ZK for the long run. From our perspective, launching a totally new ZK rollup doesn't sound feasible. No matter it's economically or business, it's not feasible. You have to migrate all the users, TVL builders to a new totally new chain. That's pretty hard. So our starting point actually was that how we can help all these optimistic rollup to compete with ZK. So that meeting actually quite interesting, came to some conclusion that actually we can add ZK proof this kind of capability onto the OP stack. So for all the optimistic rollups, they don't have to launch a totally new chain. They can use the existing community TVL users and to achieve the pretty similar finality and also security. So that kind of meeting gave us some initial idea how we should build our ZKVM. So last year, the 2023, actually we formed a small team, payment and other researchers. They started to look into this area and to find the solution, how we can make it really happen. So in the middle of last year, we brought the first white paper, and then the dev team was working on to accomplish that construction from the white paper. And now we are very close to our testnet launch, and the first use case is the hybrid rollup. So that's pretty much the background and what we have been doing until recently. Kat.
Awesome. Cool. Yeah. And also another major thing before we go into the hybrid rollup, what exactly does it mean for choosing Ethereum as the global settlement layer? Like, how does that affect the end user?
Yeah, this is a very important question. For now, I'm also the co-founder of Metis. When we started Metis, actually, our initial vision is to really scale Ethereum, to make Ethereum, truly efficient, low cost, and can be built with a lot of true applications or real world applications. So that was kind of the initial vision. And when we look into ZKM or ZKVM, we found that actually the vision is kind of similar. We cannot, it's not only we can scale Ethereum, but also we can connect all the other siloed blockchain ecosystem to Ethereum to connect all these, island together. And then it comes to this vision that we hope to settle all the transaction on Ethereum and make Ethereum the global settlement layer. So I hope I explained this. Pebble payment, you can add.
Yeah, in this case, to add on what Kevin said, Ethereum as the global settlement layer, what does that mean? He initially referred to deploying the proof on layer 1 in a completely trustless way. So using Ethereum, we can essentially submit a proof that's present on all nodes in the Ethereum network. And as a result, we don't have to depend on one single provider to hold that proof. And so we can be guaranteed that any type of computation, no matter if it's something that's generated on a blockchain, or if it's generated as essentially as general computation. So, for example, I have a game and I compute a ZK proof to it. So I can essentially use Ethereum as a means to verify that that computation has executed correctly and perform operations as a means of, hey, was this result really the result of the execution of this program, or was it something completely false? So you can essentially use Ethereum as that global settlement layer through that.
Sweet. And I think that we can address one of Laurie's questions. The first one that he asked was, how is it decided when a proof is generated for Midas transactions? Who pays for the generation proof, and which transactions are included in a proof?
Very good question. So in this case, we are launching a testnet very soon with the ability to essentially submit a proof to be generated by the prover. The prover is basically just a large machine that will take in the inputs to a program. And for the first initial version, we are using the Go language. So we're proving computation in the Go language. The prover is basically a machine that's very chunky. It'll generate the proof for that operation, and then that operation will be essentially sent to the test network of I don't think I know exactly which one. Maybe Sepolia. I think that's the one, but I guess it doesn't necessarily matter. But in this case, the proof generation, a portion of the fee would be paid for by the user. So there is essentially there needs to be upkeep for that prover within this system. And in this case, that's how the, I guess, initial version of the testnet will operate. So hopefully that answers the question that Laurie
I think to add
had.
on top of that, I think when you mention like we are using Go, you mean like something like Geth, but we compile like Geth to opcodes, like EVM opcodes to like MIPS opcodes, like low-level opcodes, and the cryptography part starts after the compilation, right? So having for the question that asks like why we are not using Rust, I think it doesn't like matter that much because like we are compiling it to like MIPS opcodes, and like we prove the execution on top of those opcodes. Like this is the ZKVM part. And I think like to answer the who is paying for that, in the first version, obviously like any other ZK rollup or like optimistic rollup, there is a sequencer, there is a ZK prover, and I think that guy is the responsible party for running the chunky machine and paying for the fees. And it can be like partially compensated by the fees that you are paying on top of your transactions.
Yeah, and also in the mainnet stage, I think it's gonna be who use this kind of service who gonna pay for this generation of proofs. Yeah.
Okay, awesome. Cool. Yeah. And to touch on what you were going into, Payman, and also to address Dimka's question of what difficulties and challenges does the team face in the development process, you're very heavy into the research. And can you kind of go through what it looks like on your end doing all this research? ZK MIPS is a very new concept, so I know that the entire community is really eager to hear more about it.
Yeah, for sure. So maybe I can take a step back and define the value of like something like ZKVM and like ZKM in my point of view. And so I think it's like undeniable for the community that ZK will unlock a new design space for applications, and you can do all sorts of cool things using ZK and like proof of execution or like on the privacy side. But the problem so far, at least to my view, is that for using this kind of magical ZK technology, you are either like limited by generating like very, very hard and like complex circuits yourself, understand the ZK technology and the math, and go through the ROS, I don't know, like all of the very high learning curves for the developers. And also it's very slow. Like ZK used to be like very, very slow, and these are the main challenges. So in an ideal world, we will have a world that if you are a like the app developer, any kind of developer with absolutely zero knowledge about like ZK technology and math, you can still use a very simple platform to build your application and generate ZK proofs for your proof of execution or like private computation. So this is, I think, the like gold quest. And I think projects like ZKM and any like ZKVM project are trying to get to this goal step by step. Obviously, there's a lot of challenges on the research and the engineering side. On the research side, we have like years of research before even like crypto, and with crypto, we have accelerated the implementation and experimentation. We started with like things like very simple ZK snarks, and then we had ZK starks, and a lot of projects are working together to combine these and like combine having the both good things about both ZK starks and ZK snarks, and having something like Plunky. And on top of that, they understood that like it's not still fast enough, or like the size of the proofs are still very like big, and there is like new advancements like folding schemes or like Jolt and Lasso lookups. So I guess my point on the research and engineering side, on the cryptography side, is that we used to have like absolutely nothing in practice like 3 years ago, and right now we are like ready for a lot of practical like applications for our daily lives, and we are making it really easier. Like in the next few years, it's going to be really fast and without the like limitation for developers and daily users of like knowing what's going to happen. And I think this is the value that we are teams like ZKM or like other competitors are making here. And inside our team, obviously the challenges was like getting like ourselves like ahead of other teams, understanding what's going on the math side, implementing them, designing something that works on the cryptography side, and on the other side, figuring out the engineering limitations, the designs that we can use for the applications, such as like ZK bridges or hybrid rollups, is something that brings value and makes the ZKM project like special, because we are not just making the like ZK projects, we are also designing and working on like the first really important applications like ZK bridges, and the first application, which is the hybrid rollup. And yeah, it's like very, very challenging to design it and take all of the parameters into consideration. I hope I answered your question.
Yeah, absolutely. I know from the inside like how crazy it is for the researchers and how hard you guys are working. I could not imagine. But also while we're mentioning like circuits and just the very technical part of ZK, Blurryface asks another question: how is it ZK MIPS is different than circuit-based snarks? I know that you probably know how to answer that, Payman.
Yeah, I think before that, there was a question about decentralizing the prover, right? I think there is like very interesting ways for that. There are like two general ways, I think, for doing that. It's basically having some kind of POS mechanism or any other network that all of them are like provers, and somehow you have an auction mechanism or any other incentivization mechanism for provers to like generate the proofs and get like something as a reward. But in these systems, the provers do all the job. Like they don't work together with the other provers. Like it's just a like round robin fashion for having your turn of like generating the proof. Another like really interesting development recently is like with things like folding or like aggregation in the ZK proofs, which basically is that instead of generating the proof all by yourself on the very, very chunky machine, you can divide it. You can distribute it to like n ZK proofs and ask like n machines and like validators to generate the proof, and you can aggregate those proofs. Like you can aggregate and like fold those proofs and break the cost into like n machines. So these are the like really like recent developments in the ZK space that I'm like personally excited. And yeah, there's like also with the ZKM's connections and like previous projects or like sister projects, we have some kind of really nice infrastructure for running them, and which are all very exciting. To answer the question about the circuit-based snarks, I think in our case, we are not even using like, how can I describe it? Like the classic circuit-based snarks, because like the first step in our current ZK structure is Starks actually, because it has like faster proving time. Yeah, but the problem is that Starks, the final proof size is like big. So like on the first step, we have like Starks, which is not like circuit based in that sense. But after that, we are applying like recursive snarks, and in the last step, we will apply like another snark, which makes the ZK proof smaller and suitable for submitting on the smart contract for verification. Yeah.
Awesome, cool. I honestly don't even know how to begin to answer back to that. Okay, cool. So we kind of like went into the research a little bit. Emzo's asking a really great question, and and Kevin, I think this is probably best for you to answer, but also would love to hear from Pavel too. How can the community help in the development of the project? What are the expectations from a community of enthusiasts who are learning about the project and really get into the idea of ZK?
Yeah, I think Pavel can answer this one. It's more related to the community and the DevRel.
Yeah, sure. So we've been trying new things within the, I would say, experimenting with different ways for the community to participate. So with Payman's answer, there's a lot to unpack, and definitely like he spends his time basically doing specific research in the field of ZK, and that's on also his free time as well. So there's like a lot of work that goes into just understanding the mechanics and mechanisms, and our goal is to make it easier to come in. Maybe you don't know some of the core mechanics and systems inside ZK technology. You might not know aspects of blockchain technology. What we're doing is we want to provide a way to make it easily accessible for people of all backgrounds to come in and engage and participate. Our end goal is for the community to come and help contribute or create applications that build on top of the ZKM infrastructure. But in order to do that, we can't right off the bat say, hey, create some ZKM programs, hey, contribute to the ZKM code base. So the best way right now that we're trying to get people to be engaged is creating the education hub. So both Alice and Jerome, the lead researcher, has teamed up to create the education hub, which basically gives a crash course into ZK. Ben, part of the ZKM team, has also created a supplementary study club. In this way, you can come in and participate in the study club and essentially learn through an interactive way. So we want to pair these types of systems together and ideally build a community of people that are interested in learning more about ZK, and then from there, people building applications using ZK. And so the best way that you can get involved is to participate within these educational programs, to contribute, and essentially to invite your friends as well to join. Because the bigger the community, the more people involved, the more ideas that get produced, and as a result, I think that we will have a easier time to get like-minded people involved in these very complicated systems.
Awesome. Yeah, I just want to add on to that, that the community's education is extremely important to us. We understand that we're working on something that's pretty big brain, and even for the team, we constantly are studying, and we just want to ensure that everyone has the opportunity to learn from wherever they need to start off from. So please, like, communicate with us, tell us where you have more questions, where you want to learn more, and we'll create the materials for you guys as a free resource, because that's the most important thing to us, is just making sure that everyone's has a good foundational education in order to move forward. And Ben brought up more about the hybrid rollup. Kevin, before we hit on that, I just kind of want to go over like the roadmap. I know essentially Testnet is coming. That's our number one message, and the hybrid rollup's coming up with that. Can you kind of give us a little bit more clarity on what to expect and how we can engage?
For sure, yeah. So the current development work heavily focused on the testnet delivery, which we hope to deliver early next month. So with the launch of the testnet program, we can run program from minigas and to generate proof, validate proof on Ethereum to go over the whole process. So with this as a background or as a foundation, hybrid rollup can be integrated, and MIT is going to be the first one to integrate with ZKM to accomplish this hybrid rollup. So that's pretty much the timeline. We hope to launch hybrid rollup this use case together with MITIS in first quarter of this year. Yeah.
Awesome. And can you go a little bit into the mechanism of the hybrid rollup, like what that would look like on MITIS once they adopt it?
Oh yeah. Just as I initially introduced, hybrid rollup actually we hope to add the ZK proof capability onto the current OP stack without need to relaunch a new chain or do a lot of other development work. So the mechanism we are heavily focusing on is the withdrawal function from layer 2 to layer 1, which we understand is a current pain point for a lot of users. If they use official bridge, they will need to wait for 7 days. So for how ZKM can help this, from the mechanism perspective, when a user, let's say, submit a withdrawal transaction, this transaction will be batched and going through sequencer and post a state on Ethereum layer 1. And at the same time, this, we treat this as a computation. It will be input into the ZKVM to run through the whole execution trace and then to generate a result. And this result will be compared with the state on Ethereum layer 1 to see if it's the same. So if it is the same, then the proof can be generated and this proof will be sent to layer 1 smart contract to verify. And the verified smart contract or the verified result will tell the official bridge that this withdrawal transaction is valid. You can withdraw fund. So then it is the official bridge will decide when they can issue the fund, either instantly or wait for a few hours. That's their choice. But for ZKM, we provide this capability for them to accomplish this function. But there might something goes wrong, right? Let's say these layer 2s, they might decentralize their sequencer, or the prover might not be honest all the time. What happened if, let's say, sequencer doing something evil, batch a different transaction, or or prover they didn't submit honest proof or generate honest proof. With this current mechanism, the proof going through this ZKVM, it will not be able to generate it. So there will be the layer 1 smart contract will notify this and also tell the bridge that this transaction might have some problem. So the official bridge can decide either they wait for another honest transaction, honest prover or sequencer to resubmit all these transactions and generate proof and going through all this process. Or they can just say, hey, I don't believe this proof anymore. I will go back to my traditional 7 days challenging period. So in this way, users' funds are still safe because we didn't change their underlying security mechanism. We only add on to make it more user-friendly and more secure. So this is something I describe in our very high level, how this hybrid rollup can work. And for users, it's gonna, especially for large funds, if they only trust official bridge to bridge in, and now we offer like a better user experience that they can also bridge out very securely and efficiently. So although they need to pay a much higher fee, but considering the cost effective is still worse. So it is still worth it. So yeah, that's pretty much the scenario.
Okay, so basically we're providing options. And there was a question that Lori asked earlier. Do you think it's possible and or feasible for optimistic chains to switch completely to ZK at some point?
Yeah, I believe Ben answered this. It's
Oh,
more about
sorry.
cost.
Okay. As you can tell, I'm barely reading very correctly. Okay, awesome, cool. So, and then where were we? Awesome. So we already went over the hybrid rollup. And Ben asked, so, well, we kind of went over what are the benefits to users as well. Okay. So next, we basically covered it all. If anyone has any, yeah, awesome, cool. And I do have a question. So we're talking about virtual machines, Kevin. How would you describe how we differentiate between EVMs versus just our general purpose VM?
Yeah, I think I can start, and maybe Payman can add something on. For us, I came from the product background. For me, I think product, if you hope a product can work and can work well, you will need to make it truly simple. If you couple a lot of difficult things all in one product, the product will collapse, either today or tomorrow. So that is part of the design concept when we see this project. We hoped first to make ZKVM a very basic and fundamental capability for every layers, for every blockchain layer 1, layer 2, to achieve this kind of zero knowledge proof capability, but without the need to develop it by themselves. And also, when we look into the ZKEVM side, as you may see, EVM itself is constantly upgrading. So you put such a very complicated technology, which needs a heavy computation and also math, into a very not very stable EVM base. This will cause a lot of trouble, which we might not know yet. But we do see something happened. Vitalik mentioned about these potential bugs in the ZKEVM, and also ZK Sync. I believe they encountered some bug in their official bridge, which is gonna harm all the on-chain assets. So we imagine that this kind of risk might happen even frequently in the future. So that's also part of the reason we hope to decouple this kind of EVM with ZKP and make ZK proof a very general and fundamental layer, which is supported by VM. Yeah.
Yeah, if I want to add, I think to put it very simply, the main difference between EVM and VM is ZKVM and ZKEVM is that under ZKEVM you can run just about any software that runs on a computer rather than anything that can run just on Ethereum and EVM. And you can use MIPS architecture, which is a set of instruction used for general purpose computing. And I think that there are a lot of technical differences, but it comes down to the fact that on the ZKVM side, it's not just about solidity and EVM application. It can be it can take a really general path. We can run so the MIPS emulator allows programmers to write in languages write Rust, C++, and Go for the ZKVM, and we can support that. And this means that we can use like libraries that is already supported, and it's like in these languages, and use them for proving like really more useful applications. On the other side, if you are just limited to the ZK-EVM, you cannot use like all of the libraries that is like already there after like decades of like development, and you are just limited to a couple of like limited codes in the EVM side. I think so. Potentially, this is like really huge improvement.
Awesome. And since we're kind of hitting on that, what Ben asks, can we touch on all the potential use cases for our ZKVM beyond the hybrid rollups? And I think that this flows evenly with what you guys were just talking about.
Yeah, I can expand on some of the use cases outside of the hybrid rollup. So the other use case is the potential for cross-chain bridging, and the power behind that is that, okay, well, we have other ZK rollups that exist that are essentially scaling solutions. They take individual transactions, bundle them together, and then post that proof on layer 1. So some examples, Taiko, ZK Sync, those types of essentially scaling solutions using ZK. There are other essentially use cases than just the scaling, and so the computation side of things is that, the cross-chain bridging side of things is that if I can prove that my assets are locked in one chain, and I can unlock those assets from an entirely separate chain, essentially in a trustless, decentralized way. So I don't have to rely on any type of third-party service provider like you do with traditional bridges now. So there's a lot of dependencies and security vulnerabilities that are present and occur with bridges nowadays. So there's you hear a lot of the hacks that are coming. There's like a wormhole bridge hack. There was something with the Ronin bridge. There was something with the with Nomad. There was something with tons of bridging solutions, and it all multi-chain as well. They all depended on essentially having their own type of validation system, and them being compromised in that way. So with the use of the ZK bridge, you only trust the essential implementation of it. Now, it still needs to be audited, it still needs to go through the checks and balances, but that's one of the big use cases, is that a fully ZK bridge that allows me to transfer assets from Solana, Phantom, to Ethereum, and other L1s, and even other L2s as well. The other use case, I think I briefly mentioned, but just the general computation use case. If I can prove any computation, I can essentially create a system where I can prove a thing, because right now a lot of operations are done in a way where I have to, let's say, offload my computation, and then how do I know that the result that I generated was that exact result? For example, like there was a big question that I had: how come Bitcoin is so wasteful, or how come Ethereum Classic is so wasteful? I have to generate essentially a random number and waste so much power, so much computation in order to get that matching nonce, which then allows me to submit a transaction to a blockchain. So I always thought, well, why can't we use that computation power for use cases that extend past that computation of a random number, or like guessing of a random number? And the main reason is that it will take you longer, or just exactly the same amount of time, to generate your own random number to verify that someone else did it in that way. So essentially it becomes unfeasible or non-realistic to verify computation, because then you'd have to spend as much time to verify it on your own machine. So might as well just run it. And in this case, like, there's no way that you can speed up this process. Well, in a ZK proof style system, you can have your cake and eat it too. You can use that. I think I accidentally muted myself. But you can use that computation power and essentially have a system where verifying it doesn't cost the same amount as actually running the computation. So I can make things much, much faster to essentially verify a specific system works. And so that blockchain use case, for example, like extending Bitcoin computation, for example, that can potentially be, not saying that Bitcoin can transition fully to like ZK proof style systems, but then you can use that extra computation and then essentially create systems where I can, from multiple different machines, attest that this computation was run correctly, and it doesn't take me a long time to verify it. So going a little bit deeper into that, probably it would be more fit for like maybe just something like reading material or something. But yeah, there are definitely many different use cases that we can take these ZK proving systems and essentially make it useful for many different areas, including scalability as well as privacy-based components. So that's my little spiel about the potential use cases, and just the ones that we're promoting. There's obviously many more.
Anything to add, Kevin or Payman?
Not from my side.
Okie dokies.
I'm good. Yeah.
All right, cool. And as we go into use cases, I kind of just want to also touch before the end of the AMA, just kind of, let's kind of go over the current campaigns, initiatives that we're working on, and where people can start getting involved. Pavel, you and I are mostly leading this. Do you want to kind of go into kind of like the contribution board and the point system?
Yeah, sure. So we were experimenting with different types of phases for the ECP. So phase one was essentially you would take a ZK MIPS circuit, you'd run it on your own machine, and that would post a proof to, I think, the Go Early testnet. We had a lot of people essentially go through the process and run that computation. Phase two of the ECP, we had people submit to Chorus campaign. So the Chorus is a platform that enables you to essentially post your contribution to the ZKM ecosystem. So a lot of them were based on like promotional contributions. Some of them were education hub contributions. Some of them were a fork and contribute. So you contributed to the code base for ZKM. The third and fourth phases, we're looking to expand it more into, we're splitting it up there's currently a chorus campaign, so you can essentially, they're more for promotional based posts, so things that occur directly on Twitter, and essentially give people a summary, like a brief summary about ZKM. And then there's Zeely based campaigns, and we want these Zeely based campaigns to act more as a means that you can essentially it's not time bound in this sense. I guess it is time bound for that month. Like you can earn however many points, but in chorus, the longer you take to submit, the less points you get. So we didn't think that was a fair model. So in this case, the Zeely campaign, once you submit the work, once it's reviewed, you will get the points, you'll get the rewards. And as a result, we essentially want to reward continued contribution over a long period of time to the to ZKM. And we want to see how people from the community can essentially stay and maintain over the long course. So you can come in, pop in, do one thing for one campaign, but the true value is we want to grow over the course of time during these different types of phases. Now, of course, if you're not, if you didn't participate in let's say the first or second, or the, even the third, there's still definitely be more phases, and we don't want that to be a limitation either. So that's the type of structure that we're looking to. We're looking to create basically these incentivization systems for continued participation within ZKM, and then we want to see ways that we can reward participation over time.
And like a really big point to everyone out there is we really appreciate your guys' participation and feedback, because it helps us grow and helps us know where we need to move forward and how we can kind of like help you, help us, help you, help us, kind of, going around in a circle there. So we're coming up on the end. I just kind of want to make the announcements of a few more things that are going on with ZKM. In late February, we'll be sponsoring and attending EthDenver. So if any of our community members are going to EthDenver, please let us know. You can also sign up for our first ever hacker house called the House of ZK at zkm.io/events. And you can sign up to be a resident. And that means that you'll be able to have housing for the full 2 weeks of the conference, or you can simply apply to just attend. We'll also be co-hosting the official opening party of EthDenver for Meet Us Fest. So let us know. Go ahead, go sign up. You can find everything on the events page, or the events tab on our webpage. And that's kind of all that we got. Thanks for joining us, guys. Thanks, Kevin, Pavel, and Payman. And of course, Ben and Alice for being my backup.
No worries.
Yeah, and thank you, Kat, for hosting. Kat is our marketing lead, so she's the one that's organizing all of these things, and big thanks as well.
Thank you so much
you.
for organizing. Thank you, the audience. Great questions.
And just one last announcement. Sorry. One last announcement. We will have way more AMAs coming, guys. So please keep on asking questions in the chats. We're always watching, and we put this into our plan for the AMA. But go ahead, Pavel. Sorry, I didn't mean to cut you off.
Yeah. If you have any suggestions for what type of content you'd like to see as well, whether it be in the study club, whether it be in these AMA style sessions, like community calls, essentially, definitely feedback is appreciated and encouraged. So if whatever you want to see more of, and again, if you have any questions about ZK or any advice even, we'd be open to hear it as well.
Yeah. Also, if you will come to EthDenver, please don't forget to apply for our hack house. Okay, thank you. Thank you, everyone.
Thanks, everyone. Have a great rest of the night, everybody. And we'll see you all soon.
Good night.
All right, bye everyone.